speedier than the surface of space-time. It can remain mindful of it and it'll basically tear. I'm terrified by this. At this point, our night sky is changing rapidly, and in an issue of numerous years, if not sooner, it might end up being completely unrecognizable. Cosmologists generally are sounding the alarm. Experts like Neil deGrasse Tyson have actually confirmed the inevitable impact on Polaris, and the story behind it is extremely surprising. Polaris, known as the North Star, has for some time been a steady presence in our night sky, serving as a vital reference point for stargazers, guides, and space specialists. However, this could soon change, altering our night sky and cosmic assessments. Let's dive into the significance of this threat and its implications for all of us. For centuries, Polaris has guided mariners and stargazers alike, standing firm as a guiding light. Its consistent presence in the night sky has been essential for navigation. However, this stability may soon be disrupted. In September 2023, an exploration paper presented by the respected Royal Astronomical Society cast doubt on the fate of this heavenly light. Polaris is near the unstable edge of exploding, potentially dissipating from the night sky permanently. Understanding Polaris. Polaris, otherwise known as the North Star or Pole Star, is special because of its proximity to the celestial North Pole. Situated directly above Earth's North Pole, it appears almost fixed in the northern sky and is located in the constellation Ursa Minor, or the Little Dipper. Polaris shines as a moderately stunning yellow-white supergiant star, larger and brighter than our Sun. It's not a solitary star. Rather, it's part of a complex triple-star system, with Polaris A and Polaris B forming a binary pair, while Polaris B orbits them. The interactions between these stars create gravitational forces that shape their orbits and affect their behavior. Any disturbances in these interactions can lead to irregular variations in the star's brightness or beat patterns. Polaris is located about 323 light-years from Earth, meaning the light we see from it today began its journey over 300 years ago. Consequently, if Polaris were to explode now, we wouldn't see it until centuries later. It's even possible that Polaris has already exploded, and we have yet to notice the light from that event. The role of Polaris in human history. Throughout history, Polaris has held significant cultural, navigational, and symbolic importance. Its steadiness made it an invaluable guide for ancient sailors navigating across seas and lands. Symbolically, Polaris represented steadfastness and direction, remaining unwavering amidst the ever-changing night sky. For astronomers, Polaris served as a critical reference point, aiding in the study of stellar movements and variable stars. As a Cepheid variable star, its occasional variations in brightness provided crucial insights into stellar properties and cosmic distances. However, Polaris has recently started displaying erratic patterns of dimming, raising concerns that it may be nearing the end of its life. This aligns with behaviors commonly observed in stars nearing their twilight stages. Potential fate of Polaris. Scientists believe that Polaris is entering the stages of helium exhaustion, typical of giant stars nearing their end. The gradual expansion of Polaris's pulsation period, an annual increase of 4.5 seconds, suggests changes in its internal structure. Some astronomers attribute this to gravitational interactions within its star system, while others speculate it could signal the star's critical edge before exploding. Despite these anomalies, Polaris is not massive enough to end its life as a supernova. Instead, it will likely shed its outer layers and transform into a white dwarf, a small, extremely dense stellar remnant. Implications of Polaris's disappearance. The potential loss of Polaris raises profound questions for astronomy, navigation, and culture. Astronomical impact. Astronomical measurements heavily rely on Polaris as a reference point. Its absence would necessitate recalibration of instruments and models used to study distant worlds and stellar movements. Cultural significance. Polaris has played a central role in folklore, spirituality, and navigation. Its disappearance could alter cultural narratives tied to the North Star, advancing our understanding of stars. As scientists closely monitor Polaris advancements in spectroscopy and photometry are allowing for unprecedented observations of its behavior. These tools help identify minute changes in brightness, providing valuable insights into stellar evolution. The study of Polaris's companions in its triple star system may also offer insights into the formation and habitability of planets orbiting similar stars. Conclusion: the mysterious behavior exhibited by Polaris underscores the need for deeper investigation and collaboration among astronomers. While its ultimate fate remains uncertain, the quest to understand Polaris and its potential demise is a testament to humanity's enduring curiosity and desire to unravel the mysteries of the universe. The broader cosmic perspective: the potential loss of Polaris serves as a stark reminder of the dynamic and ever-changing nature of the universe. Stars, which we often perceive as eternal and unchanging, undergo life cycles just as all living beings do. Polaris, despite its symbolic role as a beacon of constancy, is no exception. This realization encourages us to view the cosmos as an interconnected system of birth, evolution, and death. Stars like Polaris contribute to the cycle of creation by enriching the interstellar medium with heavy elements during their final stages. These elements, in turn, become the building blocks for new stars, planets, and potentially even life. Navigating without Polaris. If Polaris were to vanish, humanity would need to adapt to the loss of this critical celestial reference point. Advances in technology, such as satellite-based navigation systems, have made traditional celestial navigation less essential in daily life. However, for astronomers, the loss would pose a significant challenge. Ground-based observatories, which rely on fixed celestial markers for precise measurements, would need to recalibrate their instruments. This could result in temporary inaccuracies in studies of stellar motion, cosmic distances, and even the expansion of the universe. The absence of Polaris would also necessitate the identification of new reference stars in the Northern Hemisphere. Cultural and symbolic implications. The disappearance of Polaris would resonate beyond science, impacting cultural traditions, folklore, and spirituality. Throughout history, the North Star has been a symbol of guidance, perseverance, and hope. Its fixed position in the night sky inspired countless myth songs and stories across civilizations. For example, Native American tribes viewed Polaris as a guiding light, symbolizing steadfastness. Ancient Egyptians aligned their pyramids with celestial markers, including Polaris. Sailors and explorers relied on it as a dependable navigational tool. The loss of this iconic star might prompt a re-evaluation of its symbolic meanings, perhaps reinforcing the idea that even the most constant-seeming elements of our world are subject to change. Exploring alternatives. As astronomers consider a future without Polaris, they are already identifying potential successors. Stars like Deneb in the constellation Cygnus and Vega in Lyra could serve as alternative northern markers due to their prominence and stability. However, these stars are not as closely aligned with the celestial North Pole as Polaris, which means navigation and cosmic measurements might become less straightforward. Technological innovations. The study of Polaris's impending transformation underscores the importance of technological advancements in astronomy. Instruments like the James Webb Space Telescope, JWST, and ground-based observatories equipped with adaptive optics are helping scientists study distant stars in unprecedented detail. These tools allow researchers to 1. Examine stellar interiors, using spectroscopy to understand the chemical composition and physical processes within stars. 2. Monitor pulsations, detecting minute variations in brightness to study the dynamics of variable stars. 3. Predict stellar evolution, developing models that simulate the life cycles of stars based on observed data. By studying Polaris and similar stars, astronomers can refine their understanding of stellar behavior, particularly during the later stages of a star's life. A cosmic reminder. The potential demise of Polaris offers a profound lesson about impermanence. It challenges humanity to adapt, innovate, and deepen its understanding of the universe. As we gaze at the stars, we are reminded that even the heavens are in flux, constantly evolving over time. Polaris's story also serves as an inspiration for humanity's ongoing quest for knowledge. The mysteries of the universe are vast and complex, yet each discovery brings us closer to understanding our place in the cosmos. Whether Polaris continues to shine or fades into history, its legacy will endure as a symbol of humanity's enduring curiosity and resilience in the face of change. The future of stellar observation. As Polaris approaches its potential transformation, astronomers are leveraging this moment to deepen their understanding of stellar evolution. Observing the life cycle of a star like Polaris provides valuable insight into the processes that govern stars of similar mass and type. Polaris is classified as a Cepheid variable star, which means its pulsations offer a unique opportunity to study stellar mechanics. Cepheids are critical to astronomy because they serve as standard candles, helping scientists measure distances across vast regions of the universe. The relationship between their pulsation periods and luminosity is so consistent that it allows astronomers to calculate distances with remarkable accuracy. If Polaris were to change drastically or fade, the absence of such a prominent Cepheid in our night sky would drive the development of new methods and tools for studying variable stars. The loss of this convenient nearby example would also amplify the importance of identifying and studying other Cepheids across the galaxy. The role of collaboration. The investigation into Polaris's future is not limited to a single observatory or country. Global collaborations between space agencies like NASA ESA and JAXA, as well as ground-based facilities such as ALMA and the Keck Observatory, are combining their expertise and resources to study the phenomenon. For instance, 1. Space-based telescopes. Instruments like the Hubble Space Telescope and James Webb Space Telescope are observing Polaris in wavelengths invisible to the naked eye, such as infrared, to capture changes in its structure and composition. 2. Ground-based observatories. These facilities are monitoring Polaris's pulsation patterns and brightness fluctuations with extreme precision. 3. Theoretical models. Advanced computer simulations are being used to predict the final stages of Polaris's evolution, helping astronomers anticipate its eventual fate. This collaboration is not only enhancing our understanding of Polaris, but also setting the stage for studying other stars with similar life cycles. The search for life and habitable worlds. Polaris's triple-star system adds another layer of intrigue to its story. Studying the interactions between stars and such systems can yield insights into the conditions under which planets form and evolve. These findings have implications for the search for exoplanets and potentially habitable worlds. Understanding how the dynamics of multi-star systems influence planetary formation is crucial for identifying environments that could support life. By studying Polaris and its companion, scientists can refine their models of planetary habitability and improve their chances of detecting life elsewhere in the universe. Adapting to change. Polaris's story is also a reminder of humanity's resilience and adaptability in the face of change. If the North Star were to disappear, it would challenge us to reimagine our relationship with the night sky and the tools we use to navigate it. In the past, humanity adapted to the loss of other celestial markers. For instance, ancient civilizations that once relied on Thuban as the North Star had to adjust when Polaris took its place thousands of years ago due to the gradual wobble of Earth's axis, precession. This historical precedent suggests that we will similarly adapt to a future without Polaris. A legacy in the stars. Even if Polaris were to fade from view, its legacy would live on through the knowledge and inspiration it has provided. It has guided sailors, explorers, and dreamers for centuries, shaping humanity's understanding of the cosmos and our place within it. As we continue to study Polaris, we are not only unraveling the mysteries of a single star, but also advancing our understanding of the universe as a whole. Each discovery brings us closer to answering fundamental questions about our origins, our future, and the vastness of the cosmos. Closing thoughts. The potential end of Polaris, as we know it, is both a sobering and inspiring moment in human history. It reminds us that even the most constant aspects of our world are subject to change, yet it also highlights our capacity to learn, adapt, and grow. Whether Polaris continues to shine or fades into history, its story will endure as a testament to the human spirit, a spirit driven by curiosity, resilience, and a deep desire to explore the unknown. Would you like me to delve deeper into the science of Cepheid variables, Polaris's cultural history, or its future observational studies? Let me know.